Hello, and welcome to another edition of DDI's Productivity Webcast Series. I'll be your host, Joseph Richter, and today we're going to discuss part 2 of our SOLIDWORKS routing series, specifically on wire, cabling, and harnessing. The topics that I have to share with you today are, number one, a wrap-up on pipe and tube routes, that is, adding components to a pipe or tube route. For example, when doing piping or tubing, if you need to add an elbow, those are automatically populated along with the pipes and tubing. However, if you need to add a T, it's required that we go in there and split the route and then drop that component in on that split point of the route sketch. And we'll get deeper into that as I show it. Then we'll go straight into electrical route types. We'll talk about the difference between a wire route, a cable route, and a harness route. Then we'll go in and show again the routing component wizard, this time as it applies to electrical routing components. The thing that's going to be different than the last webcast is the fact that these routing components for the electrical, they require a 2D drawing block for use in the schematic drawing. Therefore, when we're generating that electrical routing component, it's going to generate that block for us, which makes that portion of it really nice. It used to be quite a pain to pull together. We'll go through standard cables. These would be off-the-shelf items, cables that you could run down and purchase at your local hardware store. We'll discuss the from-to list. We'll talk about nailboard drawing creation and finish it out on electrical conduit route. So first up, adding components to an existing pipe or tube route. In the first webcast, we showed how pipes and elbows are automatically populated when placing the route. However, in order to generate a T or maybe place another component that might be part of that route, say a valve, then that route line segment must be split. And then when you drop that T or that valve into the route based on where that line was split, and the routing point in that valve or that T, that will snap to that split point. Or maybe let's say you want to have two pipes intersecting, but yet you don't necessarily want to have a T there. We do have the ability to specify a penetrate from one pipe to the next. That will essentially bore a hole in the side of the pipe. And so with that, we'll go into SOLIDWORKS and show this. Okay, so first off, I've added in routing. So I'll just go ahead and start adding in some of these flanges. So for my design library, underneath routing, I'll go into my piping, flanges, and drag in a slip-on welded flange. And I'm going to choose my 2-inch. And here SOLIDWORKS is set to start a route on the drag and drop of a flange. So I'll go ahead and specify that I want that to drop it right in my route storage area. Once I hit OK, I verify the route properties. I want to use a 2-inch pipe, schedule 40. I'm going to have it use elbows. This is the elbow component with this configuration. I'll accept that. And then drag in my next flange. Also specify 2-inch. And then my third one. Okay, then I'm going to add a line segment to indicate additional route segments. You'll notice I'm in a 3D sketch. I can see my XY cursor feedback. So as I start drawing this first line, here I'm drawing a long X. And with that, I'll go ahead and merge these two endpoints. And as I let SOLIDWORKS regenerate here, it's going to go ahead and prompt me to save the route. I'll go ahead and do that. And then I'll hit Control Q to rebuild. I just wanted everything to snap into position so we don't get confused by this. I'll go ahead and edit the route some more. Now, here's a scenario where we may want an elbow. If I just move this line segment up and hit OK, maybe even add a relationship of coincident here. Okay, you'll notice that these pipes are intersecting. However, there's no T there. So what I need to do is I need to edit this route, and I need to split this line segment. So using the Split Entities tool, click here, there's my split. Now I'm going to go ahead and attach it to the endpoint of this line. Okay, now the reason for that split point is that way SOLIDWORKS will know where to position my T fitting. So as I go to my design library and go to my T's, I can drop in my straight T. It's going to prompt me for the size, or rather all these sizes fit, but which schedule. I'm going to use schedule 40. Hit OK for that. And now I can see that SOLIDWORKS has gone ahead and placed in that T, and I've got my pipe that's been cut to accommodate that T. I'll edit this route again, and let's say I wanted to place a valve over here. I need to go ahead and split this up. So with Split Entities, grab that and make those line segments equal. And now I have a valve already waiting for me under my references here. Here's my gate valve. Drop that in there. And then lastly, I was talking about the penetrate. Here I'll just go ahead and drop in a line segment along Z and drop in another flange. The difference this time is it's going to be a smaller flange, say a 1 inch. Maybe move it in a little bit. Now, in order to have SOLIDWORKS punch a hole in this 2-inch pipe, I need to right-click on that point and specify penetrate. SOLIDWORKS will then save this new pipe. And now as I exit, I can right-click on this, open the part, zoom out, there's the hole. So with that, I'll go ahead and edit the assembly, save this, close out, and go on to the next item in our presentation. So for electrical route types, we have the following. We have wire type, that is a single conductor that starts in one location and ends in one location. We have cables, that is multiple conductors, however they have the same starting location and one ending location. We also have harnessing. Harnesses can be one or many conductors that branch off to many different ending locations. And finally, we have a conduit route. That is a combination of a pipe or tube route and an electrical route. Can be either a harness or a cable. Now, for the routing component setup, as it applies to the electrical components, we'll talk about the routing component wizard again. This will automate route component creation by setting the connection points, the routing points, the diameter, and the type of route. And as it relates to electrical components specifically, it streamlines the creation of the connector schematic block. The connector schematic block is a 2D illustration of the connector for use in the drawing. When setting this routing component up, and we request this, SOLIDWORKS will ask us for an end face and the up direction. And here's some examples of what these will look like. So the end face will be the face selected to view the end of the connector, and the up direction to help specify the orientation. A SOLIDWORKS block will then be generated from this drawing, and it will reside in the default library location under the Harnesses Packages directory. The block files will then be created using the same name as the connector itself. And with that, we'll go into SOLIDWORKS and show this. The file that I've got for this connector here is going to be an AV jack. And I'll go straight away into the routing tools, routing component wizard. And this one's going to be an electrical routing connector. So here's my end connector. One connection point is required, so I'll add that connector point now. I'm going to go ahead and specify this face here. See that my route wants to come this way, so I'll reverse the direction. This is going to be an electrical type, and this is going to be the nominal diameter. Next says I don't require anything else special as far as geometry is concerned. Now it gives me the option to add a mate reference. I'll go ahead and add a mate reference. And I'll specify this edge here. Nothing missing. When I hit next, okay, it's asking me for the name of the component, where it's going to be located, the description, the configuration, and the library. And then here's the biggie, create end connector illustration for harness. End face is going to be this. And my up direction, I'm going to go ahead and choose the top plane. If I wanted additional views, I could request them here. I'm just going to go with the one view. And finish to close. So as I take a look at the drawing that it created, or the block, this is what it will use in my harness drawing, my nailboard drawing, with this connector. Now that this connector is ready to use, we'll go ahead and drop it into this assembly here. I'll go ahead and drag this in. Use the left, audio left. Prompts me where to save it, same location. Asks me about my route properties. My subtype, I'm going to make this a wire. Here's my outer diameter. If I wanted a covering, any other parameters, I'm going to use all the defaults. So I'm going to hit OK on that. Then I'll drag in another one. Also left side. And now with this, I'll go ahead and do an AutoRoute. Just simply right click on the end of one of these. AutoRoute. Go ahead and pick up the end point of the other one. Specify OK. I'm going to drop in another one. This one's going to be the right. One more. Also right side. Looks like those holes are too close together. I'll try that one more time. Go into the right side. There we go. Now I'll go ahead and auto route like I did with the other one. Then the last one I have to add is for the video, which is over here. Drag in this specify video. And then over there like that. Now the reason I'm dropping all three of these in here is I want to show you how to edit the wire data. So let me auto route this one more time. Okay, so now here are all my routes. I've got audio left, audio right, and video. So for my routing area, the electricals, I can edit the wires. And with the edit wires, I want to go ahead and add a wire here from a library location. And I have one set for audio-visual cables. And the wires I want to bring in are going to be audio wires. Okay, 2 of them, and 1 video. Now, the way this works, audio 1 is going to go from this component to this other component. Second audio is going to go from this component to that component. The video is going to go from this one to that one. I'm going to go ahead and save the new route. I'll name this AV route. So now when I go to make a drawing, I have all the information for the wire for each route. I'll go ahead and save this, exit out, and we'll get moving on the next item I have to show here. And that next item is standard cables. Standard cables is basically a representation of a library of prefabricated cables. These can be ones that are available off the shelf or ones that you make in-house, usually of standard lengths. The creation of these standard cables can be done through SOLIDWORKS or generated from an Excel import table. The length units must be specified in meters. Currently, that's the only unit supported for this. The part that we specify, the part number in the Excel table, will be the route name as it's displayed in the feature tree. The header row must be accurate in order to work. So here on this, you can see that my header row number is 16, and that means it starts on the 16th row. The way that these standard cables work is from the first connector reference, which is one connector file, to the secondary connector reference, which is the second connector part file. The other items that are specified in the table is the length and the diameter. And with that, let's go ahead and take a look at this. Okay, so the file that I have using standard cables. To drop in a standard cable from the routing pull down, specify electrical. It's going to be standard cables. And for the standard cables, we want to go ahead and specify our library. So as I click on here, I can specify the Excel spreadsheet to use for this. Let me go ahead and open this really quick to review this stuff. Header row number 16. You'll notice this is my header row. By the way, when adding in your own cables here, don't leave a blank row. If you do that, SOLIDWORKS will think it's reached the end of the table and it'll ignore everything below the blank row, kind of like design tables. So the part number here, this will specify the route name as is displayed in the tree. The route type Here this is for a cable route. The description. From reference, the first connector. And here's the part file that represents connector 1. This is the full path to the part file. Which config to use from that part file. To the secondary connector reference. Full path to that part file. Config to use. And the length expressed in meters. And the diameter of the route. If I wanted to add additional, I could just fill in the Excel spreadsheet here. So I'll go ahead and open that Excel spreadsheet. Or if I wanted to add a new cable right here inside of SOLIDWORKS, specify add new cable, type in my part number, give it a description, my connector reference, which connector to use, which config of that connector to use, to secondary connector, my length, and so on. If I type in an inch length here, SOLIDWORKS will automatically convert it to meters for the Excel spreadsheet. With this, I'm actually going to use one that's already in here. I'm going to go ahead and use ring -6. And I'm going to go ahead and insert this cable. SOLIDWORKS asks me where to save the route. I'll save it under my route storage. And now I'll go ahead and zoom in to place my first connector. Now this connector has a axis of rotation, specifically named axis of rotation, so I can hold down the shift key and hit the arrow keys to rotate this connector. So I'll place my first connector and my second connector, shift with the arrow key to rotate it. And here SOLIDWORKS auto routes that for me. I'll go ahead and exit the current route, exit the sketch first, prompts me to save it, and edit assembly. If I were to insert another route while I was editing that subassembly, it will become a part of this subroute subassembly. So you always want to go to the top level if you want these as separated routes. So I'll go ahead and do that again. It's going to be electrical standard cable. Next one I'll use is ring 1-0. Insert cable. Here again, where to place the route, routing storage. Hold shift, hit the arrow keys to rotate my connector. Click to place it. Drop in my second connector. Shift arrow keys to rotate that connector. And then allow SOLIDWORKS to drop in the auto route. And if I didn't like where this was, I could right click, specify move with triad. So show sketch or triad. Bring it down. By the way, because we are in a 3D sketch, this sketch or triad makes it very handy to make changes so that way it drags along these axes as you specify. Go ahead and save that route. And then for my last one here, drop in one more standard cable. And for this cable, I'm going to use a 1-3. Insert cable. Specify where to save it, route storage. Hold shift, hit arrow keys. This only works on connectors that have an axis specifically named axis of rotation. I'll go ahead and place my last one. Shift arrow keys. And there's my route. I'll hit OK on that. and save it. Now I can see that my route is actually going through my part. Maybe I want to have some clips to position the location of this route. So to do this, I'll go to my design library and find under routing, electrical, some clips. I'll drag in this clip, and this one also has an axis of rotation, so I can hit Shift and arrow keys to position it. Specify my clip configuration, and I'll do the same thing up here. Shift, arrow keys. Okay, now in order to add these clips, have that route go through the clips, I need to edit the route. So I'll go back in here, right click, edit route. And now for my routing tools, I can specify route through clip. Say I want to have this route line go through that clip axis, as well as this clip axis. So you can see the power of using standard cables and how quickly it helps you throw your assembly together. And with that, we'll save and close this. And get back into the slideshow. From to lists. From to lists are used to automate commonly used scenarios. In other words, if we route together certain components in multiple situations, then we could save time similar to standard cables by educating SOLIDWORKS routing as to how we want this route to run between these connectors. The advantage of this is we can open an existing to-from list and modify it for use again in similar scenarios. We can generate from-to lists by using the to-from list wizard, and we can either import from an existing Excel file or .xml file. So if you have an export from another electrical package, we can bring that in. Or we can create by opening an existing from-to list. The standard cables that we made earlier had actually generated a from-to list for us already. So we're going to go into SOLIDWORKS, and I'm going to show how this stuff works. For this from-to list creation, I want to point out that all the standard cables that we dropped in before already have from-to lists generated from the standard cable. So if I wanted to use the standard cable in my from-to route, I could go ahead and pick one of the ones I've already made. So on my from-to list assembly, I'll go ahead and drop in from my electrical from-to list wizard, and I could go ahead and open an existing XML library. And if I browse to my routing storage and take that XML list, okay, I can see from reference ring number 1 to reference ring number 2. Now the from part number and from pin stuff is showing up here in red, which means that that information is missing. So in fact, I think if I move this out of the way, it'll tell me this list may not be saved due to the following errors. It looks like a lot of these columns are empty. So I'd have to come in here and modify this. Rather than using an existing XML file for this from-to list wizard, I'm going to go ahead and make my own. One of the other things I did want to point out about that, I'll go back in there one more time, from an existing, same file, any one of these. Aside from these errors here, I want to point out that there is no information as to what component or what SOLIDWORKS part number ring number 1 actually is. or ring number 2. So aside from these fields being empty, there's another component here that if I were able to click on settings, in order to make a from to list, you need 2 sets of information. You need which part components to be using and the information about the wires to be using. So we have a component library and a wire library. So to get this started, first off, I need to start a component library wizard or import an existing component library. I'll show one of each. Here's the component library wizard. I want to go ahead and create a new library. Next time I'll do an import. So for here, I'll go ahead and generate a name. And for my socket, I'm going to browse to a SOLIDWORKS part file. That's a socket. Using the default configuration with a description of connector. With my pin list, I've got 6 pins in it. And then my next item is going to be a DB connector with 9 pins in it. And I'll go ahead and point it at my DB9 male part. And I'll go ahead and add 3 more pins in the list. I'm going to leave terminal size, etc. all unset. I'll go ahead and save this as a XML file called component library and hit finish. Okay, so now I have the first portion of my from to list, the components. Next I need the wire library. So to do this time around, rather than using a wizard, I'll go ahead and import a cable wire library. Import file from an Excel file. So here I've got wires. And now down here, these are the column headers that are in the Excel file. So if I take a look at that Excel file, okay, here are my column headers. My wire name, part number, description, outer diameter, color, etc. Now, for the column headers, you may have multiple spellings, like in this case, no space for outer diameter and then one with a space, or for color. As long as you separate it with a semicolon, you can dump in the number of variations that your libraries may contain. And I'm going to go ahead and save it to an XML file called wires. And it's asking me if I want to overwrite it. I'm going to go ahead and overwrite it. And here's my wire library with all this information. Here again, save it, hit OK. Now I'm ready to attempt my from to list. So from routing electrical from to list wizard, I'm going to go ahead and create a new library. I'm going to point at my component library XML for my component library area. For my cable wire library, I'm going to point at my wires XML library. And now on this page, all I need to fill out is the reference identifiers. So I'll drop in a J1. From part number, which is going to be my socket. From pin number 1 to my second reference, it's going to be J2. To part number, which is going to be a socket. And on socket, the second socket, the pin I'm going to go to that one is also pin 1. The wire name is P5V. Specification is going to be brown. Since I can't read this, I'm going to go ahead and pull it out. So there's my brown, and color shown over here is brown. I can fill the rest of this out with pull downs. To reference J2, also a socket. Next one's going to be a socket as well. J2 reference pin number 3. Here. I'm just going to try to fill this out as fast as I can. Switching this one here to a DB9. Alright, these are sockets. The ones over here are DB9s. And these are J3s. Pin 2, 3, 1, and 2, because it's a different connector. Wire names, just go kind of in order here. 4 and 5. Brown, red, orange, yellow, and green. Alright, now my from to list is going from this connector, J1, to connector, socket, which is J2, and then down here in my DB9 connector. So with start route checked, when I hit finish, I'm going to go ahead and save this as a from to list. And now because start route has been enabled, it prompts me to save my from to list. I'll go ahead and point this at my route storage, save it, and hit OK. Now I get to place the connectors. It asks me if I want to start placing my components right now. I'll go ahead and hit yes. And here I can see which connectors I'm placing, as well as a preview of each one. So J1 is the socket, J2 is a socket, and J3 is one of these 9-pin connectors. So J1, I'm going to go ahead and place over here. J2, I'm going to place over here. And my DB9 I'll place there. Now my harness type, rather my route type is going to be harness. I would then request a covering if I wanted one, where it's going to be pointing the library path. Now here's the familiar AutoRoute dialog. One thing we haven't talked about yet is guidelines. So as I click on guidelines, there are my guidelines. So I can convert these guidelines to routes. Now if I had had multiple parallel items, I could ask it to merge guidelines to form routes or join guidelines to existing routes. I'll just go ahead and convert these ones here. And from that I'll specify OK. Now SOLIDWORKS drops in a route for me. And with that I'll hit OK and save it. That's the demonstration of a from to list. And with that I'll save this and go back in to the slideshow. Nailboard drawing creation. The nailboard drawing is essentially a schematic of our electrical route. In order to generate a nailboard drawing from the pull down, routing, electrical, harness, wiring summary. When dropping these electrical routes onto our drawings, they might not always fit. So in order to accommodate some of the larger routes, we can split the line segments manually and then rotate that line segment in order to fit on the drawing. To do this, from the pull down, routing, electrical, harness, split segment. when we have connectors, especially with multiple pins, we can insert part tables. These part tables include pinout assignments for each pin on that connector, and when doing this we can also display a wire fan out. And finally, we can drop in some reports into this drawing, a circuit summary and a harness bill of material. In order to drop in the reports, it's from the pull down routing, electrical, harness, and reports. With that, we'll go into SOLIDWORKS and I'll show some of this. So to make a nailboard drawing of this route assembly, from the route pull down, electrical, harness, wiring summary, I get to specify which route, had there been multiple routes in this assembly to make the drawing from, and which drawing template to utilize. Now I'll go ahead and position this on my drawing, maybe right about here, and I'll go ahead and fix that point so that way my route does not move around. And I went ahead and pushed some of this off of the page to demonstrate the split segments. So from the routing, electrical, harness, I can split the line segments. And my first segment length I'm going to specify as being 15 and hit OK. Now I've got two line segments, one 15 and the rest, whatever the total was, minus 15. To rotate this up, I need to first delete the horizontal relationship that's at that line segment. Now I can go ahead and click and pull on this and drag it up to where I want it. Maybe add a vertical relationship. Now to get a pinout list for each one of the connectors, from the routing, electrical, harness, edit area for parts, I can specify which connector, insert the part table, and whether or not I want the wire fan out. So as I zoom in here, there's the wire fan out, and here's the pinout connector list. I can do the same for the rest of these connectors, both with wire fan outs and inserting the part table. And then the last reports that this drawing needs, routing, electrical, harness, reports, I can drop in a circuit summary as well as a harness bill of materials. Specify any additional properties that I may need and hit OK. I'm going to go ahead and save this. Now, if I needed to move these tables, I could watch my cursor feedback and drag when it looks like this, or I could go ahead and hold the Alt key down and move the table that way. And with that, we'll get back into the slideshow. And now, electrical conduit routes. An electrical conduit route is actually a combination of a pipe tube route and an electrical route. This electrical route can either be a wire, a cable, or a harness. Additionally, we could have either a rigid electrical conduit route or we could have a flexible conduit route. In order to utilize the flexible conduit route in the route properties, you can specify flexible. Now, as this conduit route is actually two different routes, the piping route and the electrical route, each routing component involved in the conduit route actually has two separate connectors. One connector for the electrical side of the route and one connector for the pipe tube side of the route. Therefore, when you drag and drop this into your assembly, SOLIDWORKS will not automatically go into start route. And with that, we'll go into SOLIDWORKS and I'll show this. And for this electrical conduit route, I'll go ahead and open this file here. And to start this route, I'm going to go ahead into my design library under routing for conduit and find my male adapter. I want to open this part really quick just to kind of show you that it has two connector points, one for the pipe tube route and one for the electrical route. I'll go ahead and drop in this adapter, and I'm going to request the 1/2 inch configuration, and I'm going to use a predefined view to place my second one. Now to start my route, I can right click on this connector point, specify start route, ask me where to save the route. I'll go ahead and put this in the same route storage location. And now here are my route properties. If this was supposed to be a flexible conduit route, I would just specify use flexible. Down here it prompts me what I want to do at each of the bends. I'm going to go ahead and use an elbow part. I'm going to specify this elbow, and I want it to use the 1/2 inch configuration. My route will be 1/2 inch schedule 40 pipe. So I specify OK. SOLIDWORKS gives me a route stub, and I'll go to the other side and add this to the route as well. And now, utilizing my AutoRoute tool, right click, specify AutoRoute. With orthogonal checked, I can now add in that other route stub, and SOLIDWORKS will throw in the best fit 3D sketch. I'm going to go ahead and drag this sketch out a little bit with edit drag. And to fully define it, I'll add one dimension. Maybe I want this dimension here to be 15. Once I've done that, I can specify OK. And now at each elbow, SOLIDWORKS is asking me which elbow to place. Since I already told it which one I wanted, that's the default, and it's asking me which configuration to use. I'll specify OK on all three of these bends. Now it's asking me to save. And now I can see all three of my elbows have been placed in there. So to drop in the electrical side of this route, I can zoom in here, specify add to route on the electrical connector point. So in order to do this, I need to edit my existing route, right click, edit route. Now I can right click on this connector and specify add to route for my electrical side. Likewise on this, add to route. I'll pull the stub out a little bit so I can see it. And then I'll go ahead and auto route to that stub there. And do the same thing on the opposite side. Add to route. And add to route on this as well. Pull the stub out. Do an auto route. And so now I have my wire and my tube. And go ahead and save these. So now I've got my pipe pieces and my wire pieces. However, in order to educate SOLIDWORKS as to what that wire is doing, I need to load my cable library. So from the routing pull down under electrical, I can specify open cable wire library. And from here, I'll just browse to a cable library that I already have ready to go. And so now, when editing that route, again, I can specify edit wires. And from the edit wires, I'm going to go ahead and add wires. And it's the marine 12-2 wire. And now I can specify from this component here to that component there. And underneath this marine cable, it's got those two cores that were from my cable wire library. It's prompted me to save it. And now I'll go ahead and edit the assembly. Next thing I may want to do with this and make a drawing from it. So I'll specify File, Make Drawing from Assembly. And I'll go ahead and specify a C size for this. Then maybe I'll drop in, say, the current view. Then from here I can insert a bill of material. So tables, bill of material. And from my templates, I'll go ahead and drop in a piping bill of material. And I want this to be a parts only BOM. And as I bring it in here, you'll notice that it has the cut lengths of each one of the tubes, or the pipes. Then I can drop in one more. And this time around, I'm going to use the circuit summary bill of material. Same thing, parts only. And as I bring that in here, it has the information on my wires from my wire route. My marine cable, 12 gauge wires, color, length, from which component to which component. And that concludes conduits. And with that, we'll close this out. Well, thanks again for joining me for another edition of DDI's Productivity Webcast Series. Don't forget to check out our podcasts that are available at ddicad.com or the new website we opened up for the podcasts, solidworksheard.com. Also, just a reminder, if you're a subscription service customer, please sign up for DDI's Customer Center at our website. From the support pull-down, specify Customer Center. On the next page, you just click on Request a Password. This will give you access to this and other webcast archives 24/7. And if you have any other questions on this topic or other SOLIDWORKS technical issues, give us a call in the Tech Center at 1-800-575-7543 or shoot us an email, support@ddicad.com. Until next time, I'm your host, Joseph Richter. Thanks and good day.